So good morning, good evening, okay, everybody. Yeah, today we are going to talk about the blockchain, and I'm going to focus on what we call the blockchain security part, okay? And what I'm going to present is actually the common flaw vulnerabilities that smart contract have all these, okay? So I'm going to focus on three major, and that's how it's going to work. So I just want to present to you my NFT collection. Okay, you can see the Black Hero NFT collection. We can have, okay, Nelson Mandela. You can have here Kwame Nkrumah. We can also have Martin Luther King and Patrice Lumumba from Congo. Okay, so this is actually an NFT collection I designed last year to showcase, okay, to bring the best of how we can celebrate our hero, our Black hero on the blockchain. Okay, so this is my contribution. So, without being said, what we are going to do is we are going to go deeper into the presentation. So, my name is MAKONGUE TOBBO. I've started as a blockchain developer, and then I migrated to a blockchain security, a smart contract security engineer, okay, where I work in freelance with people. Yeah, basically what I do is I actually read the code, understand the code, test the code to see if there's any kind of vulnerability that is actually lying into the smart contract. So I'm based in Cameroon. I also do consulting for blockchain project for people who really want to, yeah, implement a blockchain project, or people who want to, yeah, just know the technology and how that technology can be adapted into their business. So this is the kind of work I do inside the blockchain space, and also involved in trainings, companies, organization, one-to-one people. Okay. So yeah, that's why I'm actually here today, to share my experience, to share my knowledge. Okay. It might not be too much, but I just want to share what I've learned these past years. Okay. So with that being said, what I'm going to do is to share my screen and present to you exactly what you are here for. Okay. So let's just share my screen here now. Okay. I can share it now. Okay. I think it's okay now. What I can do is to put it in such a way that everybody can see it. So yeah. So as I told you, I'm going to talk about blockchain security, but I'm going to focus on smart contract attack flows. Okay, so common. I'm going to work on three of them. We are going to talk about reentrancy. We are going to talk about rug pull, and we are also going to talk about a self-destruct. It's actually a function that can be used to delete a smart contract. Okay, and this is a kind of function that someone that doesn't like you can actually use to destroy your smart contract. And if your smart contract has, okay, let's say money in it, yeah, and people actually invested in your smart contract, you're going to have, you're going to get some, yeah, some very bad nights. So that is it. So to get started, we are going to talk about the reentrancy attack. Okay. I hope you guys may know about that reentrancy attack. It's actually a famous attack that happened in 2016, I think. Yeah, with a DAO, okay, DAO hack. And the DAO actually loses a huge amount of money. So you can actually research about that kind of attack, the reentrancy attack that we are going to discuss about right now. So let me explain what is actually a reentrancy vulnerability. Okay, you have to consider that we have two smart contracts. We have one is actually a victim contract, and we have another one is actually an attacker contract. Okay, so remember we have two contracts. Let's say that victim contract, let's say that victim contract represents a bank. Okay, so we have a bank where we deposit the money, and to the other hand, we have a hacker or a scammer. I prefer a hacker, okay, who's actually going to deposit the money and then remove all the money from the bank, okay, by using some tricks. So what we are going to do now, I'm going to explain. So I see here we have two contracts. The victim contract is actually the bank, okay? So people are going to deposit the money into the bank, and the money is going to be the Ether because that's actually the value. So we assume that we are on the Ethereum blockchain, okay? Ethereum blockchain. So let's say Paul has one Ether and he wants to keep his Ether safe. Okay, he take his Ethers and then he come into the victim, into the bank. Okay, let's assume that is the bank. He puts his one Ether into the bank. Okay, we have Laura. Laura is another person willing to sell the money into the bank. Okay, Laura says, I have two Ether. Yeah, let's put my two Ethers into that bank contract. So it's going to make the contract have three Ethers, since we have Paul who has deposited one Ether, and we have also Laura who has deposited two. So the bank contract is going to be, okay, three Ethers, okay? So now we have another person willing to deposit the money, and actually the attacker. So what's going to happen? The attacker is going to deposit the money into that smart contract or into that bank and try to remove immediately the Ether that is actually deposited, and remove also the ones that Paul and Laura deposited onto that smart contract, that bank smart contract. So let me come again. Laura deposits one Ether. Let's say Paul deposit one Ether, Laura deposit two Ether. So that bank contract has three Ethers. And then we have another attacker. Okay, he has to deposit the Ether before withdrawing. Okay, so what is going to happen is that he's going to come and deposit his own one Ether, and then he's going to try to remove it by using what we call a recursive flow. That recursive flow is actually saying that remove the one Ether I've deposited, and then if there's still money, remove everything until that bank smart contract remains with zero money. Okay, and to be able to carry the attack, he has to deposit at least one Ether. That's actually what I'm trying to explain. So that attacker contract can remove the money if and only if he has deposited a certain amount. And in this case, let's say it's one Ether. Okay, I think now it's clear. So we are going to see the demonstration of that. But that's actually how it works. So reentrancy attack, we have two smart contracts. That's the recap. We have the bank account or the bank contract, and we have the attacker contract. Into the bank contract, what happened? Laura deposit one Ether, okay, and then we have let's say Paul deposit two Ethers, okay. So what's going to happen? The contract account is going to have three Ethers, and then let's say we have another attacker who is coming to deposit the money into that. And yeah, it deposits this one Ether and then tries to remove or removes the money, his money, and also removes the Paul and Laura monies to be able to carry the attack. Okay, to be able to carry the attack, it's going to implement a recursive flow. okay, so that that account, yeah, or that bank can be left with zero money down. Okay, so that's actually basically how it works. So we are going to see how to mitigate those kind of attack. And yeah, let's continue for now. We are going to explain, to make the demonstration of that. So the second kind of attack I think is actually valuable to talk about is what we call the rock pool attack. Okay, this is actually a very common, especially in Africa, but not only in Africa, even in Europe, even in US. Yeah, we have this kind of attack, this kind of rock pool attack. And I think that this kind of attack is not actually uh, an attack that has been created with the blockchain space. Okay, uh, it can be like what we call a Ponzi schemes. Okay, because we have Ponzi schemes. Yeah, we have Ponzi schemes uh, 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 player around, and yeah, rug pull can be assimilated to a Ponzi schemes. Okay, but a Ponzi schemes that is actually inside the code, a Ponzi schemes that is actually programmable, a Ponzi schemes that is actually that has been programmed by the programmers, by the developers, okay, and followed by the CEO. So we are going to talk about that. Root wall is just, yeah, I'm going to describe what's here. Here, the user are the victim. So you are the victim when you talk about rock pool. Let's say we have a protocol, and then you go to that protocol and you deposit the money to have some interest. Okay, you deposit the money to have some interest. What happened? The first month you have the interest, the second you have, the third you have, and the fifth month, the fourth month, I think, yeah, something happened. Okay, you cannot withdraw your money, you cannot put the money again, you cannot do anything. Okay, you can't do anything. So this actually kind of workflow attack. A workflow attack is the kind of attack that is run by developer themselves. Okay, developers write what we call a backdoor, okay, into the contract to be able to run away or to transfer the money to a particular address to be able to, yeah, to take the money out of the protocol. So if you have invested your money into the protocol, you cannot actually get them back. Okay, so I don't think I don't know if I'm actually explaining it very well. Okay, I'm going to come again. Rug pull. Okay, let's say you put your money inside a protocol, and that protocol is normally, okay, supposed to give you, or is supposed to give you some interest over time. The first month you receive, the second you receive, the third you receive, but the fourth you don't. Okay, what may happen? Okay, one of the causes that developer can actually program a certain function inside a smart contract to be able to transfer your money, okay, or to make your money unavailable by you so that you can actually connect and then you can actually see the money that you deposited. So you cannot actually get your money back, okay? So some in the companies with the privileged access can use that privilege to drain all the money on the protocol. So I'm going to explain what it means. So basically, that's what it's a rock pool. And yeah, to be able to understand it very well, I've took an example that is called the Africate rock pool. It's actually a rock pool that happened in Africa. I think it is in South Africa, where two brothers came up together with a platform, and then yeah, and then the platform went down and didn't yeah give back the money of the investors. So it was in June 2021, okay, founders reached out some investors to inform them that, okay, the protocol has been hacked, okay. So because they couldn't actually get the money, they couldn't actually make any transaction, they couldn't actually make anything on the protocol. So maybe investor wanted to take their money back, okay, or to remove their money from the protocol. So founders reached out, yeah, investor to say, okay, yeah, the protocol has been hacked. Okay, and then they requested investor not to contact the lawyers, not to contact the police, the regulator, or the person or the institution who's actually in charge of regulating that kind of fraud or that kind of, let's say, a business. Okay, so they say that to the investor to have time to, yeah, to let's say to transfer the money, to transfer the funds to, yeah, an address that cannot be actually traceable easy, cannot be traced easy. So yeah, they say that is going to delay the recovery process. So that's actually how it is. So after investigation, it actually turns out that they use what we call the tumblers and the mixers, okay, to make it difficult to trace the transaction. So that's actually what happened into that AfriCrypt rug pull. So there are many projects like that. You know, many people have suffered from this project. Okay, I myself in 2020, okay, I think I've been, yeah, I've been a victim of this attack. Okay, but I didn't know anything about. So yeah, so what are the lessons that we can actually learn from that? Always check that the verified contract posted by him or by the protocol or by the founders, okay, matches the deploy code on the blockchain, because they can present you a code, but that's not actually the code as it deploy on the blockchain. Okay, you have to verify that the exact smart contract. So make sure that the code is feasible, because many, let's say we have many projects do not publish the contract code or the smart contract code in the blockchain, because when you publish the code into the blockchain, it's visible by everyone. Okay, everyone can see your code into the blockchain and see if there's a problem. So you have also to make sure that that code has been audited by reputable companies. I know it is not actually, okay, a standard, or it's not a way that the contract cannot be hacked, but at least for this kind of attack, for this kind of, yeah, of attack, it is really, really important to make sure that the project has gone through some audit, okay? Because when you do a smart contract audit, you can easily detect, okay, this kind of attack, okay? Because if a firm is actually saying that, okay, I've audited that smart contract, okay, and want something like that drop will happen, okay, it's going to discredit, okay, the brand of the company. So that's why I say reputable company. Okay, so always make your own research. It is important, very critical. Don't invest in something because somebody told you to invest in that. Okay, you have to make your own research. You have to understand how it works and how you can actually, uh, yeah, make the most benefit of that. So this is actually how the rock pool attack works. So now we are going to see a code example. Yeah, that's actually that. We can see that we have a function migrate. And the function migrate is supposed to transfer the form, okay, to transfer, yeah, to transfer the form to a CEO. You can see that we have the CEO address, CEO address transfer address this balance, okay. What this contract is doing is transfer the balance of all the balance of all the contract. Maybe it can be the protocol, it transfer all the balance, okay, all the money that's actually inside the protocol to the CEO address, and then the CEO address can do whatever he wants to do with it. So this is a kind of a rug pull attack. So sometimes to mitigate this kind of attack, we can use what we call multi-sig wallet. So have like, let's say, 4 person to, yeah, to approve that, to be able to call that migrate function, okay, you have to pass through 5 people that have to assign that, okay, this actually the the CEO address, and we have to know that address, because that address is actually taking all the money of the smart contract, all the money of the protocol, and we cannot, okay, we have to know exactly where the funds are going to be. So maybe you are going to highlight it into that demonstration you are going to do with the bank, a smart contract that we have. So now we have the self-destruct function. It's actually a kind of function that can be used to let's say to destroy, yeah, to destroy a contract. And let's say we have your contract, we have your protocol, we deploy, people invested in it, and then someone creates another contract and use a self-destruct function to destroy your function so that your smart contract disappears, or all the data that has been related to the smart contract cannot be used again. So it can be very, very, very bad. So you are going to make some research about that, how to mitigate them, and yeah, how to mitigate this kind of attack. So I'm not going to go deeper into that because yeah, I don't think I have too much time to finish the presentation. So now I'm going to go deeper. I'm going to show you how we can actually use the reentrancy attack to, yeah, to swap or to, yeah, to remove all the money from a smart contract, to hack a smart contract. So we are going to do that now. Uh, so I'm going to stop sharing the screen for now, and I'm going to share the screen of the code. So let's get started. Now, where's that? So now we are going to share the screen, the screen, the screen, the screen, the screen. Let's see, share screen. Okay, we're going to share this one. Okay. No, 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 no. That's not what I wanted to share. We are going to share another screen. Yeah. Okay. This is actually the reentrancy code. Okay, I'm going to remove. Okay, we are inside the reentrancy code. Okay, so we are going to see what's going to happen right now. We are going to hack our bank. We are going to hack, yeah. So this is it. Let me share my screen for you guys to be able to see what's going to happen here. Let's see, share screen. Okay. Okay, I think now it's okay. We can actually, everybody can see what's actually inside. My screen. So this is actually the contract. So we're talking about the reentrancy attack, and we saw that we have two contracts involved. We have the bank is actually the victim contract, and we have the attacker contract is actually the hacker contract. Okay, people are going to deposit the money into that contract, that bank, and the hacker is going to deposit money into that bank too, and he's going to remove his money and remove the money of Paul and Laura. So we are going to see how it works now. But here we have some yellow colors. I don't really know why we have then maybe there's something wrong about the code. Let's see here. What's the message? The message is trying to go. This contract is payable fallback function by using. Okay. So I have to change the fallback function to the receive because we have to know that the receive is actually like an update of the fallback function. It's actually a function that is used to receive money. Okay, a function that is used to receive money. Yeah. If you want to receive money, you have to program. You have to insert the receive or the fallback function. But like I said, the receive function actually a more review and a more updated version of that of the receiving of the fallback function. So we are going to see maybe what's the difference. You can type online difference between receive and fallback function. We are going to see how they work. So let's say we have our bank contract. You can see that we have contract. You can see contract bank. Okay. And here we have a mapping. That mapping is actually a way to keep track of all the balance of the contract so that if Paul deposit the money, we can see the amount. So people are denoted by address on the blockchain. So Paul is going to have his address and is going to deposit some money. And if you check the balance, you can see the balance of Paul. The same thing goes for Laura. So now you use the function deposit to deposit the money. And once you deposit the money, it goes to that balance. Okay. So now what we are going to do is, what we are going to do is to explain the withdraw function. So that's clearly stated. Okay, to withdraw the function, you just have to click to that withdraw function. Okay, is going to withdraw what you have because you cannot withdraw what you don't have. Once you click on the withdraw function, the balance goes to zero. Okay, the balance goes to zero. And now we have a function to get the total amount of the smart contract or the bank. So yeah, we're going to see how it works. And now we have the another contract that we've been talking about since the beginning. We have the hacker contract, and the hacker contract is actually supposed to hack that contract. And we are going to see the function that does that. This function attack. And the other function is also this function, that receive function, used to receive headers. Okay, and that's actually the statement I was talking about. If I'm trying to say that if the address or the balance of that contract is still greater or equal to 1 Ether, then remove that money. That's actually a recursive loop. And once it's going to click on that button, that attack function, everything is going to set. Okay, it's going to deposit the money and it's going to withdraw the money. Once it's withdraw the money, a recursive loop is going to happen, like the receive function is going to say that if there's still money in that contract, if the money is greater or equal to 1 ether, remove that money. Okay, so basically that's how it works. And we have another function here to get the balance of the smart contract. Okay, that attacker smart contract. So now we are going to demonstrate how it works. Let's see, now we compile it. Once it's compiled, we are going to come here and we are going to try to deploy it. So we are going to remove those old contracts. So you have to listen to me very clearly here because that is demonstration. I think we understand most by demonstration than talking, but it's really important to set the base before the baseline. Okay, that's actually theories. Don't you are into this first address. So we are going to deploy the contract. So we remove everything. Yes. Okay. We are going to click on deploy. Okay, and we have two contracts here. We have the bank and we have the hacker contract instances. So we are going to click on the bank because we want to deploy the bank first. Once we deploy the bank, we can see that an instance has been created. So what is going to happen is that you can actually deposit money, you can withdraw, you can check the balance and check the balance of the bank. Okay, so let's say we've been talking about Paul and Laura. So let's say the second address is Paul, who's going to deposit 1 ether. Okay. Let's say we come here, we say 1. Okay, we come click here on deposit. Okay, 1 is being deposited. This is the address of Paul, the second address. So we copy that address, we come here, and then this is the balance. You can see the balance of Paul. We can say Control V, and then we click on balance. You see that Paul has 1 ether. And we can also check what's the money that's inside that bank contract. So we can click here, that button, get total balance. Click total balance, we can see there's 1 ether as well into that contract. So we are going to deposit Laura's money also, and Laura is going to deposit 2 ethers. Okay, and Laura is the third address. So we land in the third address. Okay, now what we are going to do, we are going to deposit 2 ether, let's say 2. Okay, and then we are going to click on deposit here. Okay, let's click on deposit. Okay, and then let's verify what is inside the smart contract, what's inside the bank. Click here and you can see that the bank has 3 ethers. So the smart contract is functioning very well. Now let's say we have to check what Laura has. Okay, we click here to copy, and then when you come down here, we can actually remove that address, Control V, and click balance. Okay, we are going to see 2 ethers. So the address of Laura has 2 ethers. So the contract is functioning very well. Now we are going to deploy the hacker's smart contract to be able to remove those 3 ethers that you see into that bank. So how are we going to do that? We're going to just come here, okay, choose that instance, that hacker smart contract instance. So I'm going to land here, and then what I'm going to do, I'm going to copy the address of this bank smart contract. Okay, when you deploy a smart contract, it has an address, and that address here is going to be the address of our bank. We're going to copy the address of the smart contract of our bank or the address of our bank. So we are going to come here, click, copy it. We are going to deposit here, Control V, and then we are going to deploy. Once we are going to deploy, okay, that contract by using, when we are going to deploy that attacker or hacker contract, is going to take control of the address. It's going to take control of the bank contract through its address. That's why we are pasting the address here. Okay, let's say in this code, maybe I've not explained it. So we can see the address of the contract of the bank. Okay, that's the bank address. So to deploy the hacker contract, it needs to have the address of the bank that has been deployed, okay, or the address of the smart contract that's actually the bank. Okay, when we take it, we come and paste it here, we deploy it, and once we click on the button deploy, it's going to take control of that smart contract. So let's say deploy, okay, the transaction has been validated very well. And then we are going to open that instance. See very well. Now we have attack, we have bank address, and we have the balance. So we can click on the balance now. Okay. Let's say the balance is 0. Okay, the balance is 0. Nothing is inside it. So what we are going to do, we are going to choose another address that's going to act as a hacker address. So let's choose the last one. Okay, once the last one has been chosen, what we're going to do is, yeah, we are going to run that function, okay, that attack function, and we are going to see what's inside that attack function. And to do that, let's say we want to deposit a certain amount of money. Let's say he wants to deposit 1 Ether and then remove his Ether and remove the other Paul's and Laura's Ether that's actually inside that bank. Okay, let's see inside the code. This is the function attack. Okay, it's going to deposit the money. Okay, 1 Ether and going to remove the money. Okay, once that function is being activated, that receive or fallback function is going to be triggered so that if there's still money in that contract, remove it. Okay, so that's why we have to deposit the money before removing it. And not remove something that it doesn't have. So what we are going to do is that we are going to click on attack. And once we click on attack, you deposit and you withdraw immediately. And another function is going to get triggered. It's actually a receive or a fallback function, whatever you want to use to call it. So once we're going to click on that button, it's going to have 4 ethers. So it's going to have is 1 ethers and the other 3 ethers that is actually inside that smart contract. So let's say click. Okay. And then we're going to see the get balance. The balance is actually 4. So the contract did not have anything before. Now the contract has 4. Where did he take it? He took it from that bank smart contract, because if you go up there, okay, and maybe you click get balance, voila, you click get balance on the bank account or the bank smart contract is now 0. Okay, if you click here, the balance of that address, the balance of that contract is still 0. Okay, so the attack has been successfully conducted. Okay, and that attacker's contract has taken all the money from that smart contract. So first of all, deposit the money, okay, and then you try to remove your money and remove all the other people's money that's inside by using what we call a recursive loop. that is actually saying that if there's still money in that contract, then remove it. It's actually the fallback function. So there are ways to mitigate it, and we have what we call checks, effect, interaction pattern, and also the use of libraries. Yeah, one of the most used libraries is actually what we call Open Zeppelin. Okay, it's actually mathematical libraries that helps calculate or perform some mathematical formula so that it can secure the code. So we have the checks, effect, interaction pattern. We are going to make some research about it, and I think we have too much time to talk about it. And yeah, the use of the libraries. So basically, that's what I had to explain to you to that session. So to recap, we talked about the reentrancy, we talked about the rock pool, and we saw that the reentrancy has taken, okay, all the money from a bank. So has been a hacker has written a smart contract that that went and hacked the bank contract. Okay, so we see how we can actually hack a contract with another contract by using what we call a recursive loop. Okay, the rug pull attack is a kind of attack where developers of the project or CEOs in connivance with the CEO of the project, okay, try to steal the fund from a protocol, from a platform, okay, by using what we call some backdoors into the code. So many people have been victim of that kind of attack. And we also talked about the self-destruct function, where I said that we are going to make some research about and maybe come to the forum and explain how you can mitigate, how you can run this kind of attack, because it can be a very serious attack. Let's say you have your contract and you have the money inside, you have your investors, your contract is running well, and then someone, program a smart contract to attack another contract or attack your contract, and your contract stop functioning. You are running billions of dollars or millions of dollars, and then you cannot proceed anything. You can't do anything anymore. So it's something really critical. So it was a pleasure for me to talk to you, to let's say to present to you the blockchain world, this blockchain security, because we talk about blockchain, we know blockchain is secure, but sometimes blockchains are not secure because we have uh, network vulnerability, we have software vulnerabilities, we have codes vulnerabilities that can impact actually the security of the asset that is being deployed into the blockchain. So thank you very much. And I hope we see in another session. Thank you, everyone.